Anyway, I will admit right away, and I do this at every presentation, whether it be at Reinforce, reInvent, my Deniverse, or a local meetup like this, I talk fast. It is my number one problem. So please interrupt. I will not be offended. Talk over me. Make sure I stop so that we can address any questions that there are in the room. Absolutely happy to dive deeper on any topic or come up with material if I can come up with reference material to provide you guys at the end of the call to help. All right, so today we're going to talk about an overview of AWS IAM. This is AWS Identity and Access Management, not all organization and multi-cloud identity and access management. I know we like to name things our own way, even if it's already coined by the industry. So sorry for the confusion. My name is Jeremy Ware. I'm a security specialist solutions architect at AWS, and my primary domain of expertise happens to be identity and access management, both for workforce and consumer. All right. So the most important question we all get asked by every auditor is who has access to what? And the hardest thing to prove, especially in AWS to date, is who has access to what. So the job of AWS IAM is to control who actually has what access. When we start looking into the who, so we're going to break this out into parts. What we're really talking about is the IAM identity or the calling principle that's created in AWS. Now, this could be in the form of like a root user, which is the first user that gets created when you set up a new account in AWS. This could be an IAM user, which would be like a long-term credential, username, password. They may leverage access keys. So this was traditionally used early on into AWS access. And I believe still prevalent today. A lot of companies use them as service accounts. And then we have IAM roles, which is more so best practice. And that's where calling principals can assume a role into AWS, and they are vended temporary credentials. That is exactly how it works with Identity Center as well, if you guys are familiar. So when we're talking about workforce ingress, you don't have to federate directly to the IAM service. You can also use IAM Identity Center, formerly known as AWS SSO, in order to gain access. While the credential or the federation to Identity Center can seem like a long-term credential, under the hood, it's still doing an STS assume role call in order to grant you temporary credentials. So now the most important part about calls in AWS is how do I attestate or how do I authenticate that it is a valid call, right? And this is where SigV4 and SigV4A come in. And so anybody on the call, has everybody heard of SigV4 signing? Okay. No, that's perfect. Perfect. Mixed bag. So SigV4 is the signature that AWS appends to every request or every API call that you make to the platform. That signature is verified by IAM for every single call. Roughly 1 billion calls per minute, I believe, is now the current public metric. And that's how we verify that the incoming request is valid and ready to be evaluated. So this happens before we even do permissions evaluation. It all starts out with a secret access key. This is a pretty standard behavior. You have an access key. You want to go ahead and take an HMAC usually of it. And that's what you would use as a signature. But in order to become more secure, what AWS does is we do layers and layers of envelope encryption. So we start with a secret key. We go ahead and take an HMAC of that, and then we create a new key called the daily key. And this is actually tied to the actual date that you're making this request. We then wrap it again with a regional key. So let's say it's a Cognito running in US East 1. That would be the regional keys for US East 1. And then we add the service key. So in this case, my example, I'm actually calling Cognito. So now we're going to implement the key that's tied to that service. And then lastly, we're actually going to get the signing key. And that's where we take the HMAC of the service key, wrapping the regional key, the daily key, and the original secret access key. All of this to say, we have layers and layers of envelope encryption so that if anyone were to try and break this down, just take a long while, right? It's not impossible, but by the time it was done, the request would no longer be valid. One of the most important things that I want to point out here is as we walk through the layers, some customers are a little bit confused on how this works when we start talking about it. They believe that every single call has to go through this envelope encryption process, or I guess not encryption, envelope hashing process. I apologize. Um, and the truth is we don't, because the regional key, the daily key, those are going to be set for the day in the region that those calls are done. And the system is able to actually cache those. So we take secret key, we set up a daily key, and that's where you would start if you change regions. If you're doing another call within the same region to another service, we start at the regional key, we add the service key and do a hash of that, right? So there is some efficiency built into this process. Sorry, I want to touch one more point. I said envelope encryption. I really meant envelope hashing. I apologize. Very, very different. Hashing is one way, encryption is not. So what happens when we go to authenticate a SIGV4 signature, right? The string that we're actually going to sign is going to include a couple of different points, predominantly the actual algorithm that we're using. It's defined as AWS S4 for SIGV4. It is a standard HMAC and SHA-256. We get our date, range credential, scope, and hash canonical request data. And that is a very long hash. As you can see, it includes quite a bit of information there. So what happens when we put it all together? Well, we get our actual signature. And that signature is going to be passed in the authorization header of the request. So when an API call comes in, for example, to Cognito, like I mentioned earlier, let's say update user, we hit that API endpoint. What AWS is going to do under the hood before it even evaluates if the calling principal has permissions to do the update call or update action is we're going to validate the authorization header. We're going to see what credential they're using, what region it came from. We're going to go ahead and check what service we're tying to, and we're going to validate that signature, which is the most important thing. SIGV4 signing and SIGV4 advanced signing has now actually been expanded. It used to be something that only we did under the hood or could be made available to you via the SDK. There's now an open source project so that you can actually use SIGV4 signing for machine-to-machine communication. I think IAM roles anywhere is probably easier, and we'll touch on that here in a little bit, but that is an option to you depending on your workload requirements. All right. So now we understand how we sign an API call. Now, how does my role or my principal actually get credentials, right? Because we've all seen long-lived credentials. We're used to the behavior of a username and a password, whether you're using two-factor or MFA or anything else included. I have a single username and password, and that gets me my credential. That is my credential. Well, when you assume a role in AWS, you are vended a temporary set of credentials that are valid on AWS, mapped to the permission set of the role you assume. So the most important part here is that when you make an assume role call, you are hitting STS, Security Token Service, which is going to vend you those temporary credentials. And we call it an access key, secret access key, and session token. And we'll kind of break that down here in just a little bit. So what happens if you don't have an AWS identity, right? That the IAM role has not been configured directly into IAM. Yes, I can absolutely do that, Keith. And I'll copy those questions kind of at the end to make sure I address each of those and get that out to everybody as well. So if you don't already have an IAM user set up or an IAM identity, it's not set up directly for IAM Federation assume role. There are a couple other mechanisms that you can do in order to ingress or work your way into the AWS platform as a workforce user. One of those is setting up IAM Federation, right? So for this example, if we wanted, we could go ahead and configure a SAML integration with IAM. It's called IAM Federation with assume role with SAML. Pretty straightforward naming scheme. SAML essentially is an XML doc and an open standard. Well, it is an XML doc, but it is an open standard which defines IDP to SP authentication. We leverage the IDP or identity provider to handle authentication. And then based on sending that XML doc or what we call a SAML assertion or response to the service provider or SP, it validates that the federated user is who they say they are, right? So what you would do as an external identity is you would sign into your IDP. This could be Okta, Ping, any other third-party solution. Once you had authenticated to that service, you would be able to see all your list of tiles, right? One of those would be AWS. You would click on the appropriate tile. And what that actually does under the hood is it kicks off a IDP initiated sign-in where it sends that SAML assertion over the wire to AWS IAM. And IAM Federation would validate that the assertion came from the proper IDP and is valid for assuming a role, and then would exchange credentials to the user via the browser. Any questions high level about SAML? Okay. There's another standard that we also use for gaining entry, and that is OAuth or OIDC, which is the enhanced version of OAuth. Essentially what it is the exchange of JWT or JSON Web Tokens, which can be cached in the browser, either in your request as an authorization header. It can be stored in the body of the message, depending on how big it needs to be. But essentially, it is a token-based authentication service as opposed to leveraging like the XML doc like SAML. It operates much in the same way. So you can still set up direct IAM federation using an OIDC identity provider. Most of the identity providers or third-party identity providers that manage enterprise-level workforce users do support both SAML and OIDC. And so IAM supports both, just to make sure we cover all of our bases. But essentially, the user would still sign into their third-party IDP. The IDP would then issue them a token, a JSON Web Token, and in the form of OIDC tokens, it would include an identity token, access token, and a refresh token. If you're just doing standard OAuth flows, it's just going to be your access token and refresh token. And the difference there is the access token is what is actually used per standards for authentication. The identity token provides extra context about the calling principle that can be used downstream for authorization decisions. And that can be done in applications or in the form of IAM Federation, allow you to set session policy based on data that comes over in that OIDC token.
So quick question. To make either of these work, you have to set up a security relationship with the identity provider, correct?
Yes. So to configure IAM Federation, you would be required to bring over certain assertion documents from your third-party IDP to register. And then we'd set up a trust policy on the IAM side that would say if you received the assertion from this appropriate third party and it has the appropriate signature, so that someone who uses Okta at another company is not federating into your AWS environment, then you can go ahead and assume a certain role.
Okay. And one other question with that, and I'm a little bit more familiar with JWTs and OIDC. Do you have different claims in the JWT that would be used to define the role, or is it basically whatever roles are enabled for your user identity?
That's a really good question. So you could configure determining criteria based on group membership, for example. So if I had IAM users that I wanted, or if I wanted to federate to IAM from a third-party IDP, I might leverage the role that can be assumed based on context that I should receive in that token. So for example, if you want to assume an admin role, you must be a part of the group administrators or something similar.
Okay. Thank you.
Yep. One of the things that's really helpful is really with IAM Federation and a third party, whether you're using SAML or OIDC providers, is the session policies, right? Because then when the assume role comes in, you have that original assertion or JWT, and you can set up session policy based on its context, which is really, really helpful depending on how your organization is set up. All right, and let's look at one more use case. What if I don't have an AWS identity, but I'm a machine workload? I'm not a human user. Traditionally, we're all probably familiar with Active Directory on-prem and the use of service accounts for workloads to communicate on our protected network. Now, unfortunately, the world has gotten a lot more complex and technology has scaled well beyond what I will ever be capable of learning. And so we have a lot of new methods for handling machine-to-machine communication without using long-lived credentials. Um, Case in point, a lot of the breaches and events that we see get published, especially lately, are because access keys or credentials were embedded in the application and somebody accidentally exposed it or committed it to a public GitHub repo, those kind of situations. The use of short-lived credentials for machine-to-machine, whether it be through MTLS, client credential flow, using JWT tokens, or in this case, IAM roles anywhere, is really to help combat that, right? We don't need hard-coded credentials and applications. So there's another way to access or ingress into AWS for machine-to-machine. If you have workloads running in GCP, Azure, or on-prem in some colo somewhere, you can leverage your existing PKI, public key infrastructure, and issue out X509 certificates. Your workloads can then pass that certificate along with an assume role request to IAM roles anywhere. IAM roles anywhere will evaluate the incoming cert and ensure that it's been vended by the approved, we call it a trust anchor, but the approved certificate authority. And if it matches all the requirements and it was vended by the approved certificate authority, then it will execute an assume role on your behalf and pass back temporary credentials for your workload to do what it needs to do in AWS. Any questions on that one? I know IAM roles anywhere is relatively new in the AWS space. Okay. Feel free to throw them in chat too, and I'll make sure that we cover all of them. So what does IAM federation look like? We could set up group to role matching, which is pretty common, role-based access control, right? Which we're very familiar with. There are some levels of attribute-based access control that you can do, like I mentioned with session policies. But for example, I might have a DevOps engineer that needs to assume a DevOps role in AWS. And I would just simply match the group membership or that role-based access to the current role that they're going to assume in AWS. The most important thing to note here is that when you do IAM federation, it is direct to the individual account in which it is configured. So IAM federation allows you to federate to that account. What this has caused as a pain point for a lot of customers is that as we've moved to a multi-account strategy and we start looking at orgs on high who now have dozens of accounts, hundreds of accounts, worked with a couple of customers who are now in the thousands of accounts. And this becomes really difficult to manage, not only just the scale of who has access to each individual account, but the amount of cross-account assume roles, because you want to have a single account for people to ingress into, and then they all start doing this role chaining, which gets really hard to then verify who has access to what to follow principle of least privilege. Scaling out those permission sets without drift also becomes a bit of a challenge, depending on if everything's infrastructure is code or if people are manually operating within the CLI or the console. So very common problem. So what AWS did to help alleviate some of that stress is the introduction of Identity Center, formerly known as AWS SSO. What Identity Center allows you to do is it is deployed in your management account. It is the one instance per your organization for as far as workforce ingress into AWS. And it allows you to map, whether it be role-based access or another methodology, who has access to not only permission sets, but a multitude of accounts. So when a workforce user, let's say a data scientist, signs in to Identity Center, what they're going to be greeted with is what they're used to seeing on an SSO page, an Okta, Ping, or another SSO provider, is a list of tiles. Each one of those tiles allows them to assume a certain role in a certain account. And this allows you to centrally manage it and audit it, which has been very, very helpful for a lot of customers. It's not perfect. So
Jeremy. So yeah, hey Jeremy. Just asking some questions about, like you mentioned, how difficult it is to manage when you've got all these assumed roles and the logs end up being clogged with a lot of random IDs that don't seem to map anywhere. Is that the best strategy to manage that, or do you have any other suggestions on how to, enable, better auditing?
Yep, really good question. So there's a couple. One is migrate what you can as far as bulk of workload for workforce ingress to Identity Center if it's possible. To that point, it's not foolproof, right? No solution is absolutely perfect. Identity Center today does not support multi-federation sources or OIDC providers, for example, which have been stop points for some customers. Now, what we have seen, especially large enterprises do, is they end up doing a combination thereof. 80% of their workforce is usually behind one IDP. And then as they're doing acquisitions and allowing external access and so on and so forth, they might support other IDP mechanisms. But those are usually more restricted as far as the amount of accounts and the sprawl in which they need access. So they manage those with IAM Federation and the bulk of the workforce through Identity Center. One of the other things you can look at doing as well is looking at Access Analyzer. So IAM Access Analyzer 3 years ago was very new and only really supported about 15 services. IAM Access Analyzer today now supports just about every service. And it allows you to look at not only unused access for restricting permissions, but to start looking at cross-account access. So you can set your zone of trust to be a single account and run an audit of which other accounts or roles have access to assume role into this account to access your resources or access directly to resources.
What was that called again? I'm familiar with that one.
Yep, IAM Access Analyzer.
Access Analyzer. Okay, thank you.
Yep, and that one is, it is a relatively new service. Like I said, only a couple of years. It is ramping up very, very quickly. Just at reInvent this last year, they announced unused access, last accessed, which can both be used to help starting pushing towards principle of least privilege permissions. But also you can now define your zone of trust as either organization-wide or individual account-wide so that you can see who has access to resources in each of those zones of trust. They also allow for custom policy checks, which we'll talk about a little bit later when you're looking at implementing permission evaluation into like a CI/CD pipeline, for example.
Thank you.
Yeah, absolutely. So we've discussed the who. Now it's access to, right? The who has access to. So how do we govern that? Really, we have categories of IAM policies. They each have their own title. They each have their own use case. They each have their own place. And that does not make it easy. So to give you a little bit of background, people often forget IAM was not the first service AWS authored or offered, right? S3 and EC2 both came before IAM. What we came out with IAM was grant permissions. And that's really what we took all the way until 2015, were only grant types of policies. And a grant is what you're similar to today with Active Directory or IDP. I've added you to a grant or a group, and that grants you permissions. I've added an attribute to your principal, and that grants you access. Now, what AWS realized really quickly was we had too many people who were restricted by the plethora of actions and protected API controls that AWS has for the multitude of services, and it got really cumbersome to figure out what access they needed. So they started using service star, worst case scenario. So AWS responded, the last several policy types that we've released over the last 8-9 years have all really been guardrail policies. And a guardrail policy is meant to scope down access, predominantly either deny or setting maximum permissions so that we can leverage that implicit deny to restrict access, and explicit deny, sorry. So 2 quick types. We'll go over policies that are associated with an IAM user role or group. So these are like your IAM entities or principals, as we would call them. And that's your identity-based policy, service control policy, permission boundary, session policy. And then on the other side, we have the resource-centric policies. And these are going to be like your resource-based policies and VPC endpoint policies. When we get into the actual language of IAM, show a quick example here. It's really important to note that there are several statements that make up a policy. With each statement, there are 5, or excuse me, in referencing those statements, there are 5 primary elements that we want to cover. So first is we have the effect. The effect is either allow or deny. That's exactly what it sounds like. I'm either granting access that's listed below, or I am denying access listed below. Allows are very common in identity-based policies. and in resource-based policies, especially in the case of cross-account access. Deny policies are something you see a lot more, for example, in an SCP or on a resource-based policy if I want to scope it down to an unless type of condition, right? So deny access to this resource unless your role is data scientist, or deny access to this resource unless role is security professional. Next, we have the actual principal. And so this is who's allowed to execute the following action on whichever defined resource is there, or denied access, right? If the effect is deny. You can define all roles within an account. You can define your root user only. You can define a specific role. All of that can be sourced with the ARN. There are mechanisms for cross-account access that we'll talk about in a little bit that may change how you define your principal and where you put your principal in order to make cross-account access a little less cumbersome, depending on your level of risk. But predominantly, after the effect, we have a principal, and we've defined the one or many principals or role ARNs that we want to be granted or denied access to the following action. The next element is going to be the action, right? And one's pretty straightforward. This is the action that you're going to allow or deny, right? So S3 put object, X3 get star. This could be EC2 run instance, right? Any type of action that we want to grant or deny based on this policy statement. Next, we're going to have the resource, and this is the target of the action. So in this case, we have an effect allow for some role to either S3 put object or get any object, as long as the object is within example bucket. And then lastly, we have our condition statements. Conditions are not a required element, but they are often used in order to provide more context and more fine-grained permission. So for example, in this one here, we state where AWS secure transport is true. So as long as TLS is being leveraged, in the request to get or put an object to S3, we will allow the action. If that flag were false, then they would be denied on this action because they wouldn't meet the condition. So grants don't necessarily have to be all access all the time. You can use conditions to scope them down. But guardrails are exceptionally helpful in reducing identity access. All right, so let's break the two types out a little bit further. So when we talk about grants, like we mentioned before, this is exactly what we're used to seeing. We have an IAM role who wants to access a resource. And so we've defined at the identity policy that they have access to S3. Now, there is an exception with a resource-based policy that may also be a grant. So the resource-based policy may say, if you have this role, you have access to this bucket. Now, quick question. If you are within the same account, do I need one or both of these policy types in order to access the resource? Correct. I only need one. There is an inherent acceptance of trust within an account. We use an account as a hard guardrail. If you have conversations in your organization about data perimeters, for example, account isolation becomes a really strong data perimeter. But within that account is inherent trust. So what customers will often find is, for example, if I don't have a resource-based policy, but I have a grant in my identity-based policy, or vice versa, I will still get access to the resource if it's inter-account access. Now, does this change when we look at cross-account access? Yes, absolutely. We no longer have that zone of trust at the account layer. And so now I need both an identity policy from the calling account that says I have access, and I need a corresponding resource-based policy that says the calling role from the other account has access to the resource in order for you to have access. This is what prevents someone from accidentally granting themselves access to the wrong bucket. Let's say you grant yourself access to a bucket of some other organization because you got the bucket name wrong, and they are globally unique. You would not inherently have access to that resource because it's not in your account. There would have to be a corresponding resource-based policy. Same with the opposite. Someone can't just grant themselves access to your resources. You would have to have the applicable resource-based policy that would grant the external principal that access. right? The harder one is guardrails, and we have a lot more policy types that fall under the guardrail policy. And so these are predominantly your scope down mechanisms. Now, SCP is the one we are probably most familiar with, service control policies. These are deployed through organizations. One of the most important parts about an SCP is that while it's at the organizational level, I may attach it to the organizational level. I may also attach it to the OU specifically, or down into the nested account within that OU. And so scoping an SCP and where you apply that scope is really, really important, because an SCP is basically a hammer policy, right? It is a do not cross go, deny statement explicitly, and that's predominantly how it's meant to be used. These are the cases, things that you throw into SCPs would be like child accounts are not allowed to self-withdraw from an organization, right? There's no use case where they would need to be able to do that. We'll put that in the SCP. Non-security personnel don't need the ability to delete cloud trails or change security service configurations. There's almost no exception for that. You would define that in your condition statement of the SCP, and now you would know at the organizational level you're okay. Now, there are some things that may be OU or account specific. You may not want to deploy to certain regions for certain workloads. And so you might include that in an SCP to scope down the regions that you are allowed to deploy resources in. This helps to ensure that you have logging and governance of the actual regions you're deploying workloads in, and that you don't have things that you're not actually tracking being deployed. But the regions that you do for one workload may be different for another. And if you have proper account separation, we might have a different SCP for each of those accounts or OUs then. Lastly, very important to note, it is not a mistake on the slide. SCPs do not affect the management account. So the management account where you log into Control Tower or Identity Center or manage SCPs for the organization is not affected by SCPs. So really important to note.
Yeah, I'm going to ask a question because that was always a concern, that if you did some sort of a deny on your management account, you could completely screw yourself. That's been fixed?
That has been fixed. So you can no longer apply an SCP to the management account. We had some customers who, on the inverse of that, got concerned that, well, now I can't lock it down. AWS best practice is that very few people should ever have access to the management account. Even in the form of Identity Center, you can register delegated administrative accounts. So I might have a security OU where I have a logging account and I have a security, let's say security hub and config are being managed in one account, Control Tower that I'm leveraging, delegation to Control Tower. But I might have a delegated administrative account specifically for managing Identity Center without needing to have access to the management account, right? So there are definitely best practices to architect for that security. But yes, now you won't accidentally lock yourself out and then have the 2-week turnaround with AWS to prove that it should be manually removed. All right, next one is permission boundaries. So SCPs, I think everybody was probably pretty comfortable with. Do people know what permission boundaries are? Okay. Most people get it wrong anyway. It's super convoluted and we don't express the use case very well publicly. It's something we're working on now. Permission boundaries essentially are a additional policy that can be tied to an identity policy that sets the maximum scope of permissions available to that identity, regardless of what their identity policy says. So the primary use case is not that you would apply a permission boundary to every identity that comes into your organization, but rather, for example, we want to grant developers access to create role so that they can create roles for Lambda functions, EKS clusters, right? To be able to go out and reach out to the back end of the service and do what it needs to do. But what we don't want is developers creating star roles that elevate their own privileges and give them access to things that we don't want them to have. So a secure way of doing that is to grant them the create role action in the IAM policy under the condition that they attach a specifically defined, use the ARN, permission boundary to anything they create. So the developer itself doesn't have a permission boundary on their role, but any role they create has to have the permission boundary attached for them to create the role. Otherwise, it's denied. And so the use case here would be something like a developer isn't quite sure what permissions they need, so they grant DynamoDB star for the Lambda role or the service linked role for Lambda. And in actuality, there's a lot of different tables that are maybe merged and they only need access to one table. And so the permission boundary scopes down to that specific table. Even though there is an identity policy that states they have access to DynamoDB star, a permission boundary operates as if everything not allowed in the permission boundary is denied. So it acts as an explicit deny for anything not listed in there for permissions. You don't have to go through and list all the denied actions, though, which makes it a little easier and less cumbersome. All right. So again, holistically, a developer creates a role for an application. It's an application role. It's called a Lambda function role. Lambda invokes that role, and it has the permission boundary attached to its identity policy to do put object to a bucket. As long as both the identity policy and the permission boundary provide access, it will have access. If either deny access or do not explicitly allow, it will be denied. So let's kind of look at what one of those might look like. So if we had a developer role and we want to go ahead and attach a policy to that role, we might have effect allow. The action would be IAM create role because we want them to be able to create these roles for services. But the resource would be anything. They can attach it to anything they want, create role, anything they want. But the condition is that they must include this permission boundary. And in this case, we defined it as the specific ARN under policies, PB for permission boundary. As long as that is attached to the role that they create, they're good to go. If they do not attach that role, the create role function will not work. This has been really, really helpful because I don't know about yourselves, but prior companies I've worked at, everything related to permissions went straight through a centralized security team. And while that is fantastic for security, we have a lot more developers than we do have security folk. And so we become a bottleneck, which becomes very painful for accelerated growth and for earning trust with development. And let's be honest, security does not get the same support that developers do, usually, as it relates to being a costing org versus a value generating org, right? So this is one of those ways that we can ensure good security best practices and ensure that we've scoped down their permissions to what they should be, while allowing developers to operate and fail quickly. So what does a permission boundary and application role look like together? And well, I know we talked about it, but I kind of want to run them through together. So if we have an application identity role, right, the service link role, for example, that has effect allow S3 put object on any resource, and we have a permission boundary attached to that role that says effect allow S3 star actions on any resource, what's the expected outcome of this? If somebody tries to do S3 put object, will they be successful?
Yes.
Yes. Yep. They have the identity policy and the permission boundary allows at least that action, right? It may provide more, but it allows at least that action. Now, what are session policies? These aren't often used. So please don't feel that you have to use every policy type at AWS in order to get some type of credly badge or be doing things perfectly efficiently. That is not quite how it goes. There's no unlock or secret jacket that we'll send you. Session policies are unique for managing attributes that come along in an assume role call and govern actions that are valid for that specific session. So for example, let's say you have an IAM role and it wants to go ahead and do an assume role. So a cross account assume role, or this could be role chaining. A service linked role is going to assume a role in order to take some action. We're going to provide those temporary credentials from STS to give you that second role. But then we're going to have your identity-based policy and a session policy for that specific session of that assumed role that may affect the permissions that you have. So maybe IAM role 2 has certain permissions tied to the identity-based policy, but I have a session policy that says if this role is assumed by an external principal and not one that I've defined in this group, then the session policy is enacted. And that session policy is, again, going to scope down or guardrail those permissions. So if I want to access an S3 bucket, both my session policy must not prevent and my identity policy must allow for me to access it. VPC endpoint policies. So one thing that we've done very, very well for a long time is be dependent on network infrastructure in order to evaluate zones of trust. A VPC endpoint is exactly what it sounds like. Any egress or ingress into your VPC goes through the endpoint. You can apply endpoint policies so that you can state if a workload is reaching out or reaching in to the VPC to access resources, that it must adhere to this policy. VPC endpoint policies like S3 endpoint policies are leveraged a lot when accessing internal resources by workloads running in the VPC. Very, very common use case. All right. Pick it up a little bit here. So policy evaluation, this is the hardest part of all identity in AWS. We do have a few tools that now make this a little easier. So Access Analyzer also has Policy Generator, which helps you go through and generate good policies based on the actions that you need. It is not absolutely perfect, but it is far better than the old UI and IAM of just creating a policy and having it yell at you for syntax errors or Java error with an inconsequential number and value there. The biggest point to harp on, and we'll cover it at the end as well, is that AWS policy requires during evaluation an explicit allow. We have explicit denies that we adhere to, and we have an implicit denies that we adhere to, but there is no implicit allow across AWS. No action will implicitly grant access. Really, really important. A deny also always overrules any allow. So if I have an allow in my identity policy, my session policy, and my resource policy, but I have a deny at the SCP, the deny wins. So when we look at authorization context, this is what actually gets sent to the data plane authorization endpoint for any service when you're trying to make API calls. It is a conglomerate of principal data and control plane data that's provided by the service. And what we end up getting is a whole bunch of context that we can map against our applicable policies to authorize the request or deny access. So we're going to get the principal, which is going to be one of our AR, AS, or AK numbers, random alphanumerics. We're going to get the action they're trying to do on which resource, and then we're going to get all the applicable context. So we might get information about the session. We're going to get information about their account that it's coming from, the organization ID, which is really, really helpful now for governing access to resources and sharing within your organization instead of explicitly allow listing every individual account. We're going to get information about the service role, whether MFA was present, time, tags, etc. All of this data is then going to be evaluated against the policies that we have to see if this calling principal making this action on this resource should be allowed. So what does that context look like? John uses an IAM role to get object myfile.txt from bucket example bucket. So as we kind of break these out, we have our role making the request. It's going to be John, right? And the action is going to be a get object myfile on the resource myfile.txt in the example bucket. So let's go ahead and map what our policies are and then see against our authorization logic whether we have any line up here to allow or deny. So we have a couple of different statements here. We have 4 statements in the identity-based policy. We have an allow, get object, and put object for objects in example bucket. We have a deny S3 put object on any resource. We have an allow for DynamoDB, and we have an allow for S3 get object under bucket other buckets. So we'll go ahead and we'll start lining these up. The matching statement, we have action S3 get object. We do see an explicit allow of S3 get object. Our resource is the example bucket / myfile.txt, which was one that was approved in our allow. And then we have a lot of additional context. So let's go ahead and start matching those up. We have our principal ID, which does match statement 1. The resource that we're targeting is in example bucket. And as you see, the resource in our statement 1 policy is a direct match. So now we know we have an allow for this action in this specific bucket on this file. But now we need to go through the rest of the statements to make sure that we don't have any denies. So as we jump into statement 2, we have a deny of S3 put object. So on any resource. So we're going to go ahead and quickly evaluate against the authorization context. Any resource, we are affected, but what's the action? It's a get object, which does not match put object. So we don't have a match. We can throw that deny out. It doesn't matter for this authorization decision. Third statement is an effect allow, but it's for DynamoDB. It's not related to the service or the resource that we're calling, nor the action. So we can throw that one out as well. And lastly, we have statement 4, which is allow S3 get object on other buckets. While we have an allow, it's for a totally different bucket and file, so it doesn't really apply here. So we can ignore that one as well. So at the very end, we have statement 1, which allows and matches. Statement 2 doesn't apply, and statement 3 and 4 can also be ignored. So this request would be allowed. On the other side, if John uses an IAM role to create bucket example bucket, the role making the call would be John. His target is example bucket, and he's trying to do the S3 create bucket action. When we look at the same context for this action on this resource, what we see is we have our defined resource of example bucket. We don't have an allow for get object, put object doesn't apply because this is for anything inside example bucket. Statement 2, deny put object. Again, any resource matches, but the action does not correlate. So it's not tied. Statement 3, again, is DynamoDB. So it's unrelated to the current authorization decision. And statement 4 is S3 get object from an unrelated bucket. So it doesn't match either. So in this case, the allow only grants access to /star, right? Which means the content of the bucket, but it doesn't allow them to change or create the bucket. As such, request would be implicitly denied. There wasn't an explicit deny. There was not an applicable explicit allow. So implicit deny. We'll do one more. I know these get a little tough to walk through and watch. So John wants to do put object myfile.txt into bucket example bucket. We have our role as John. What's the resource? That's right. It is myfile.txt in example bucket. And the action being performed is S3 put object. So now when we walk through those same statements in the authorization decision, we do see that the resource matches, right? We are affecting a resource inside example bucket. And the action is S3 put object, which we do match in our allow statement. So statement 1 matches. Statement 2 is a deny statement of S3 put object. What we see is our resource is tied to resource star, and our, action of S3 put object does align with the action. Now the effect of this statement is deny, and statement 2 does match. So we have a match on statement 1 and a match on statement 2. Different effects though. So before we even go through the next 2 statements, anybody have an idea of what's going to happen for this authorization decision? Correct. We have an explicit allow, but we also have an explicit deny. So regardless of what the other statements say, the explicit deny overrules. In both of these statements, they can actually be ignored because they're not applicable. Because we have an explicit deny and it matches, we get an explicit deny. Deny always overrules. And so again, just to reiterate, you have to define an explicit allow for somebody to have permission. If no allow statement is provided, implicit deny is always the response. And explicit denies always overrule explicit allows. Now, what does the policy evaluation chain really look like? I'm going to show it in steps here because this kind of shows the scope going from organization down to principal, role, boundary, session, etc., down to the resource. But in actuality, these are basically thrown into a tumbler and we evaluate all at once. So first you have an incoming request. As soon as that request comes in, we're going to evaluate any policy defined at the organization. So if there's no service control policy denying the action, it will proceed forward. We're then going to look at identity-based policies once you've gotten into the account. We're going to assess any permission boundaries tied to the role. And then we're going to check any session policies that apply to that specific assume role session. If all allow, then we're going to go ahead and allow that request. Now, We didn't mention resource-based policies here because this is assuming that they're within one account. If you were doing cross-account, then again, you would also need and allow the resource-based policy in order for all of this to work. All right. So I know I touched briefly on IAM Access Analyzer. Essentially, if anybody used Access Advisor, that was a different project or a different service, but very similar to the early stage of Access Analyzer. Access Advisor basically granted you access to look at last accessed as a report, which basically goes in and evaluates every action that a permission set grants, and when the last time that the role or persona tied to that permission set used said access, right? So it can be really helpful in auditing to scope down permissions. There is a better way to do that now with Access Analyzer. So instead of looking at each individual role or each individual IAM user one at a time and going through last accessed, I can set up unused access findings at the scope for zone of trust of my account or my organization. So you can do both. Unused access now has a built-in dashboard that will provide you details about unused access keys, unused IAM users, or unused actions tied to IAM roles or permission sets in mass, so that you can quickly go through and remediate over permissive permission sets. It's also going to allow you to detect public and cross-account access. So public access would be if the zone of trust is set at the organizational level. I can then see anywhere where I have resources that have explicitly shared access to an external identity. But if I scope that zone of trust down to the account level, I can still see any external to the account. So again, we're talking about that account boundary. I'm sorry?
Sorry, that was a mistake. Please go.
Oh,
Please
okay, no
continue.
problem. No problem. At the account zone of trust, so that you can see any of the cross-account access that you've already granted and then go through and audit those as well. It's really, really helpful. Policy validator and policy generator. So the validator is going to validate policy structure and basically result back in the impact of said policy to make sure that it's in accordance with what you intend. The policy generator is going to now assist you in creating IAM policies that allow you to access certain services. Helps with things like syntax and condition statements to provide suggestions to make sure you're getting what you want. The last access is also here as a part of unused access. The last one I want to touch on is custom policy checks. So I mentioned this earlier. One of the things about identity that's really hard as we start enhancing the way that developers access AWS, right? Because it's changed. Originally, when people were first getting into the cloud, application teams or developers had a credit card and they went and stood up whatever they wanted, right? And security was brought to the party way later. Governance after the fact became difficult. Getting involved became difficult. Lifecycle management, permissions management, all of it became very difficult. But it was because developers had to access via AWS CLI or the console direct in order to impact or create workloads, right? That was the only way to do it. Now there has been a lot of support that's been built not only for CloudFormation templates, but leveraging the CDK which uses CloudFormation under the hood, or other third-party infrastructure as code tools like Terraform, right? We have Account Factory that leverages Terraform for that integration with Control Tower, so that development can be done through infrastructure as code, and we can get individual developers out of accessing the console and the CLI. As long as they can commit it via code, they don't need access to the platform. What that allows us to do is start implementing security checks proactively instead of reactively, right? Everyone here hates the auditing and the following up and the alerts way after the fact and then telling someone they can't do something they already did. Now it's in production and it's some 3, 6, 9, 12, maybe we'll never come back and fix it kind of issue, right? Reactivity is good. Incident response is important, but proactive is better, right? If we can outright prevent a potential issue, we always want to go that route. When we start leveraging CI/CD pipelines or infrastructure as code deployments to AWS, we now have a unique opportunity to start putting in gate checks. One of those things that you can do outside of meeting current coding best practices and things that QA and dev probably already go through today is to evaluate permission policies in real time as a part of the CI/CD commit process to validate that they are not over permissive, and that they are following current best practice. So for example, you may want to ensure that no one has the ability to delete a CloudTrail. And a developer wants to be able to write to CloudTrail on things that are happening in their Lambda function. Totally reasonable use case, but they're not sure what they need or what action they need. So they just put CloudTrail star. As a part of that commit process, you would do an evaluation by hitting the IAM Access Analyzer endpoint, custom policy checks. If any policy includes CloudTrail delete action, it would be denied. And in this case, CloudTrail star includes that action. So the CI/CD would kick back a failed to commit. You did not meet this standard requirement. We provide a nice little error to your developer. And the developer, instead of going through an identity team and saying, I need this, what do I need? Someone create the policy. It's going to take 6 weeks, can quickly go back in and say, oh, I don't need that. And I can look up the 3 actions I need for CloudTrail or just write to CloudTrail and include that and quickly make the commit again. It's the same kind of thing that you can do with Code Catalyst blueprints. If you guys are familiar with the Code Catalyst tool for pipeline management for deployments into AWS accounts throughout your organization, you can create blueprints that set standards for all pipelines or for individual pipelines. It is a great opportunity for security to be involved in the development lifecycle and set those standards without having to change the entire culture of the company and being a part of every developer's meeting and really doing it in a way that's not operationally successful. All right. Sorry, soapbox. I get really excited about shifting security left into the development process. Any way to enable development and ensure high standards of permissions is a pretty big deal. So quick question for everyone here. Do developers have access to create roles or policies in your organizations today? Yes. Okay. Okay. Are you guys leveraging permission boundaries, do you know, in order to reduce kind of their level of access? Some places, maybe not everywhere, maybe everywhere.
For us, we have sandboxes where you basically have admin without permission boundaries.
Okay. Yep, and depending on the risks, very common use case. I see a lot of developers where, as they go through dev stage prod, their access dramatically changes on that life cycle. In development, we've given them a sandbox. We want them to go test and break things. That's the entire point of a developer, to build and build fast and reiterate and enhance and improve. Our job, though, is once it gets to the next stage of QA and testing, and then eventually to prod, is to ensure that nobody else can manipulate prod or make mistakes, right? And that's where privileged access management really comes into play. There are things that can be managed via CI/CD pipeline, but every once in a while, someone has to go into production, right, and make a change. Hopefully, not everyone has access, and we can kind of scope that down to privileged escalated access. Things like leveraging a ticketing service like ServiceNow to cut a job that's going to change an inline policy for a developer role in prod temporarily once approved by leadership that this action needs to occur, right? And then after the fact would go ahead and execute a task that would remove that policy because the developer no longer needs elevated access. So super common. I see both. I see developers have access. It may or may not be governed. And I see we've had too many incidents or events that were unintended external access that did not look very good for PR. And so we have removed developers' access. And then the problem there becomes is development becomes very, very slow if security is the bottleneck. So both are very common patterns. Anything that AWS or your account teams can partner with you on to improve this process, we are absolutely happy to do. I recognize that I geek out about identity all day. It is all I do predominantly. It's about 85% of my job description. And that's really exciting for me. But for anybody who has to manage microservices and customer policy and, all the other aspects of security or IT infrastructure, identity is the last thing you want to bang your head against the wall for. So we're always happy to help partner. All right, almost done here. So safe roles and policy delegation. What does that look like? We mentioned that we could have a developer who's committing things to a CI/CD pipeline. As it goes through policy validation and linting, that may be something you've built as a custom check, maybe something where you're reaching out to IAM Access Analyzer custom policy checks to handle that for you. And then we're going to deploy to infrastructure, including an identity policy, and that would be used for some backend service. That create role becomes the application role, and we're going to ensure that anything they create also has to have the permission boundary attached to it. So as they create the identity policy, as long as they've set in to include the permission boundary, they are good to go. This is this architectural pattern right here that we just discussed of developers accessing via CI/CD and using permission boundaries to scope down their application roles is AWS best practice today. This is not where most customers are. Because we just recently, in all fairness, relatively recently, expanded to the multi-account strategy. We now have customers doing multi-orgs. AWS documentation just this last year acknowledged multi-cloud. I'm sorry that took so long. So this is current best practice. And if this is something that you do want to work for, at least for your most sensitive workloads, this is probably where I'd start heading, and those are the ones we'd target first. All right, and now we are at the very end, last couple of slides, and we're talking about the what's. We've talked about the who, we've talked about the access to, and now it's what? What are the resources, right? There are several ways to manage your resources. We can do resource-based policies like we talked about. You can reuse Resource Access Manager. So for example, talking about IAM roles anywhere, I had a customer who was looking at automating the cert rotation to on-prem servers using the SSM agent. And the primary fear was now that every application team would need to have their own cert authority, and that could become extremely cumbersome and extremely expensive. What they did instead was they set up PCA and AWS as a centralized cert authority, and then they used RAM, or Resource Access Manager, to delegate access to that PCA down to the applicable application teams and their accounts. And then they were able to set up those zones of trust and the certification requirements of what would come over in their vended certs, so that they didn't have to manage the PKI infrastructure themselves or make it really cost prohibitive. So this is a great option. One thing to note with RAM that is very, very important is if you are getting ready to change orgs, or you eventually go through a merger acquisition and need to adjust the org, anything that is shared via RAM, the sharing account obviously maintains access because it owns the resource, but any sharee, any account that's being granted the access, would lose it if it's not a part of the same organization as the granting account. RAM is an organization-dependent resource share. So very important to note. We've had a couple mishaps as customers changed orgs. You select your resource, choose the permissions that you want to allow. You can specify the specific principals in one or many accounts, and then you share the resource. So pretty straightforward and easy. Another one we'll talk about briefly is tagging policies. I wish it was supported everywhere in AWS, but unfortunately ABAC is not. Where it is supported, it is very, very effective. So ABAC, for example, for EC2 is pretty well supported. The ability to tag EC2 instances and snapshots and so on is pretty well supported by AWS today. So we can add context via these tags and in your permission sets via conditions to allow access. So for example, if Team Unicorn and Team Zombie both operate in the same account and same region and manage EC2 instances, we don't want them stepping on each other's resources. So as long as their instances and fleets are appropriately tagged with their team identifier, I could add a condition to their identity policy statement that states, dev Team Zombie has access to, EC2 star under the condition that EC2 instance is tagged with Team Zombie, right? That's the key value pair. That prevents those development teams from stepping on and deleting each other's resources, which is a huge pain point when they are not separated by account. All right, so what does that look like? It's a key value pair, right? So you define the key. In this example, we're using cost -center. Hyphen is not applicable or a valid tag, or a valid key, but you would set your key like team, group, role, industry, department, and then you would have applicable values that you could then leverage in your conditions to look for that key and evaluate the values or list of values that are approved to take the action on the resource. And with that, I want to say thank you. I know everybody has been listening to me ramble for the last hour, and that can get to be a lot, especially this late in the day. So I really appreciate everybody sticking with me here and not snoring openly on a mic. If there are any additional resources that you want to look at, we have a couple that I think are really good publicly. We have the IAM deep dive documentation. We have security best practices for AWS IAM. And then we do have two of the four policy evaluation video series have been published. Hopefully the other two will be published very shortly. They're going through the final edits. They are pretty lengthy. Matt Luttrell, who I believe gave the prior presentation and was slated for this one until he had a conflict, was the author of all four of those videos. Policy evaluation has been kind of a great point of interest for him for a very long while. They are a bit lengthy. They're about an hour long. But they go very much in depth to what we've talked about and then examples of the different types of policies and how they might be used in conjunction. Right.
Cool, thank you.
Ooh, URL for open source project. Yep. Let me try and find that. I believe we have it in a AWS samples repo.
And it's not critical. If you can get it to Rob, he can get it into the Slack. But it would just be nice. Having implemented SIG v2, it's nice to have something else implementing the SIG v4.
Find it. If I can't find it in the immediate moment, I will make sure I get it shared out with Robert to share with the group.
Sounds good. Will do.
Any questions for me?
I notice you're recording. Is this going to be posted somewhere? Because I can think of one person I really want to hand the link to.
Yes, it is, and I'll make sure that gets to Slack.
Perfect.
Excellent.
And
Thank
again,
you.
anybody who needs access to our Slack workspace, just send me your email address. A good way to do it is through Meetup.
If I can find the chat, here we go. It's an ugly link because I did a link to highlight. But this will take you to the SIG v4 Identity and Access Management Guide. At the bottom there, we have our SIG v4a signing examples and how to integrate it into custom code.
Great. Thank you.
Yeah, no problem.
Does that
All right,
answer the question about, like, in your presentation, Jeffrey, you mentioned about the best practice now about enabling developers to create roles using infrastructure as code. Is that an example of how to do that? Or at least the best practices on how to implement that?
SIG v4 signing is more of an authentication mechanism for like machine-to-machine communication. It is one method that developers could use for their workloads. But the CI/CD or infrastructure as code development would be more so how they interact with the platform to deploy assets on the platform.
So where can they go to find more information about that, or how can they present this so that we can adopt the current best practice versus what we're currently doing?
Yep. Let me. I think we have it in our code catalyst documentation. And again, if I don't find it really quickly, I will ensure I get it shared out. But let's see if I can find it.
It only takes us 6 weeks to generate a new credential.
So is the question more so about the architectural pattern or about doing custom policy checks and evaluations so that they can?
You're gonna love my answer, yes.
That's good. No, that's a good question. Both are important. Let me start with custom policy checks, and I'll send you that one. So here's a quick blog we just published on the launch of this feature end of last year. And then let me also send you documentation on permission boundaries. We have a blog that we did, I believe, last year as well. on best practices when evaluating and using permission boundaries. Those would be used in conjunction, right? So we would have Access Analyzer to evaluate permission sets are compliant that developers want to commit or create. And we would use permission boundaries to scope down what the role they do can actually do as a guardrail, right? The last one is the CI/CD process for developers to ingress into AWS. I don't know if I have like a public blog that talks about the architecture, because we talk about it a lot in our pipeline documentations. Yep, unfortunately, several pipeline services: code build, code star, code commit, code pipeline, code catalyst, to name a few. It's a bit of a pain point, but I will look. I think it would at least be worth looking at the code catalog, code catalyst main page here. Oh, paste in. Let me change that. Sorry.
I don't think that the service matters in as much as the architecture pattern. It should be the same. It's just the implementation is going to differ slightly depending on how you're doing it.
Correct. Yep. You are correct. Let me see if I have. We usually talk about directly to services in our documentation, which is not necessarily the best. If I can't find it immediately, I'll reach out to, the identity service team has a specific group of essays that support just the service team. I support service team and customers. I'll reach out to them and get a copy. If I can find any documentation, I'll make sure I get that shared with Robert, because I would like something a little bit more prescriptive than Service General.
Absolutely. No, much appreciated.
Yeah, not a problem. And Robert now has my email as well as Matt's. So if any other questions pop up, please feel free to reach out. Like I said, I enjoy my job. I geek out about identity. So it's exciting for me to talk about this and improve the security maturity of customers via identity. So not a problem at all if anybody wants to have a quick conversation or anything like that. Okay.
Well, thanks,
Any more
everybody.
Yeah, thanks, Jeremy. That's great.
Yeah.
Thank you, Jeremy.
Great talk.
Thank you.
Pleasure.